Hello, this is Engineer Arun Kashyap from CAT desk head office. Today we'll understand the following topics. Let me define bullets. First is graphical user interface of CATIA V5. Second topic is workbenches of CATIA V5. Third is slider crank mechanism. We'll be defining the mechanisms of a slider crank with sketcher. And fourth one is animate constraint. Now let's draw the slider crank mechanism here. A slider crank mechanism is used to convert rotary motion into linear motion or vice versa. Let's draw a circle and then crank, connecting rod, then piston or slider component. So here we have slider crank mechanism on the right side, as you can see. Now let's launch the CATIA V5 and see the changes. CATIA V5. Let's see. To launch the CATIA V5, let's right click on the icon of CATIA V5 and click on the OK button. Here we have the interface of CATIA. Let's close this. First tab is start button. So when you start, we have all these things in infrastructure, mechanical design, shapes, analysis. In infrastructure, we have all those mechanical designs. Shape, we have surface features, and then analysis and simulation, AEC, plant, machining, and then digital mockup. We have the kinematics over here, equipment and systems, and then digital process for manufacturing, then machining, simulation, and design analysis, knowledge, and NVIDIA. Next is Innova V5 VPM, then file manager we can send, and then edit tab, then view tab in which we have toolbars, then insert, tools, we have image to capture, album, video, macro, and all those, then window, and then help. So these are the tabs available in menu bar. Now let's see the other thing, which are our first topic, which was graphical user interface of CATIA V5. let's see. In first tab we have start button. In machine design we have the workbenches like sketcher. So let's go to sketcher and with a name like slider crank mechanism, and make sure that you have click on enable button, enable hybrid design, and click OK. Here we have feature specification tree. So graphical user interface will be talking about some topics, like first topic is feature specification tree. So let's see, this is our feature specification tree, in which first is slider crank mechanism, name of it in the project, and then all three planes x, y, y, z, and zx, and finally we have the part body. Next is view manager. In view manager, here we have a view manager toolbar in which first is fly mode. View manager allows us to see the model in different views, zoom in, zoom out, normal view, and obviously then create multiple views, isometric views. In isometric, front view, back view, left view, right view, top view, bottom view, and then height components and all those. These are the view manager buttons. So first we will be trying the fly mode. Just click on the fly mode. Fly mode allows to user to look into the objects, and click on the fly button, and click on the left mouse button and drag your mouse in the direction you want to look into, and just you can shift according to dragging of your mouse. Fit all in, makes sure that all the objects in normal view, position the object in the normal position, and isometric view gives the information of three orthogonal views simultaneously. You can also switch in different views like front, top, right, etc. just by clicking on the button of front, top, and right. Let's go to render style, parallel render style, and click on the top view button. So it's the top view. This is the isometric view. So here we have all the views, and this is the render style without edges, render without edges, render with wireframe only, render without edges again. So these are the visual styles. So this was the view manager, and next is planes, front, top, and right. Here we have three planes in CATIA V5. First is XY plane, which is and these are the three planes. XY plane is the top plane, as you can see here. This is our top plane, and then YZ plane is our front plane. Let's take a sketch, get out of the sketch. ZX plane is our side plane or right plane, you can see. So these are our major three planes. Now next we will be covering the triad. Triad have three axes like X, Y, and Z. Here on the right top side we have a triad. We can also take sketch by triad. Next is file manager. File manager allows us to manage the files like copy, paste, and all those. So first is to create a new file. You can create a new file at any time just by clicking one button. Next is open. Make sure that you are going to open some prefabricated or pre-made files. Save is to save your file at any location. Just click on the save button. Next is to print, quick print, cut, then copy, then paste, then redo or undo, and then all. So this was our file manager. Next is profile toolbar. In profile toolbar we have different geometry sketches. Let's have a sketch on the front plane. So let me drag this. This is our profile toolbar, in which first is profile command, next is rectangle command, then circle command, then spline, ellipse, line, axis, and points. So these are the major commands which we can cover in this profile toolbar. Next is our operation toolbar. In operation toolbar we have the corner, which is also a fillet, chamfer, trim, break, quick trim, close arc, complement, and then mirror, symmetry, translate, rotate, scale, and then finally offset. We also have projection, 3D projection element. So these are our operation toolbar. Next is constraint toolbar. In constraint toolbar we have constraint defined dialog box, then constraint, contact constraint, and next is fix together, auto constraint, then animate constraint, edit multi constraint. So these are some commands. Next is sketch toolbar or tools. So in a sketch toolbar, first is grid command, next is snap point, then construction geometry, geometrical constraint, and dimension tolerance. Next in which we are going to focus is exit workbench. Here I have a sketch, and on the top, but here we have a button of exit workbench so that we can get out of the sketch. Next so here we have completed with graphical user interface of CATIA V5. Now let's go ahead with workbenches of CATIA. Workbenches. So in this segment we'll be discussing different workbenches of CATIA V5. Now let's see different workbenches of CATIA V5 available. Let's go to CATIA, and first is start and then infrastructure, product structure, material library, CATIA V4, catalog editor, photo studio, immerse real-time rendering, product data filtering, and these. Mechanical design we have part design, assembly design, sketcher, product functional, weld design, mold tooling design, structure design, 2D layout for 3D design, drafting, composite grid design, core and cavity, healing assistant, functional mold, sheet metal production, composite design, wireframing, surface design, generative sheet metal, and functional tolerance. Next is shape, freestyle, sketch treasure, imaging, disto, generative shape. Then likewise these all are the workbenches of CATIA. Next is analysis, advanced machining and generative structural analysis, AEC plant layout, machining, lathe machining, prismatic machining, surface machining, advanced machining, NC manufacturing review. And then digital mockup we have all the kinematics types like DMU kinematic, DMU fitting review, DMU optimizer, and all those. Equipment and systems we have electrical equipment designs, conductive design, and electrical hams, harness discipline, HVAC discipline, multidiscipline, and preliminary layout, and piping discipline, and tubing discipline, structure discipline, circuit board design, and all those. Next we have digital process of manufacturing, machining simulation, design analysis, knowledge, and Innovia V5 VPM. So these are all the workbenches of CATIA. Next is slider crank mechanism with a sketcher. In this segment we'll be sketching the slider crank mechanism with CATIA V5 with the sketcher workbench of CATIA V5. So here we have slider crank mechanism, in which we have crank, piston, connecting rod, slider crank mechanism as name. Now let's take a look on the definition of slider crank mechanism. This is a slider crank mechanism shown above, as you can see. And a slider crank mechanism is defined as a mechanism, or the slider crank mechanism is used to transform rotational motion into translational motion by means of a rotating driving beam and a connecting rod and a sliding body. So driving beam, rotating driving beam is a crank here, connecting rod as you can see, and then sliding body is a piston. Now let's draw the slider crank mechanism with the sketcher workbench of CATIA V5. Let's draw this. Let's take a sketch on this and give it a name, slider crank mechanism. Click on OK button. Let's take a sketch on front plane, which is YZ plane, and let's drag all these toolbars downward. Click on the select simple corner rectangle to make slider component, and then fix together all the edges of this rectangle and make another rectangle adjacent to the top side of this rectangle, and then another rectangle adjacent to the bottom side of the slider rectangle. So here, as you can see, I can adjust it accordingly. Now let's give all the constraint and then define a straight slot for defining the connecting rod. So this will be our connecting rod. Next will be our crankshaft. This is our cranks. This will become our crankshaft, as you can see. Now let's adjust the length of connecting rod and crankshaft in an appropriate ratio, and let's just double click on the fix together and fix this anchor point of the connecting rod along with all those sides. And now we have fixed one side of the connecting rod. Second thing is to fix the crankshaft's points. So let's just click on this point and click on the define by dialog box and click on the fix and OK. So here we have fixed the anchor point of our crankshaft also. Next thing is to adjust the level of slider crank. Let's adjust this. So now let's fix the length of the crank also, just by giving the dimensional constraint. Let's give it a value of 50 mm, and fix the length of the connecting rod also. Let's give it a value of 100 mm. So we are going to give the ratio to the length of the connecting rod to the crankshaft has to be 1:2, and then let's give an angle constraint to the connecting rod, which will be animating. Let's give it a value of 45. So we are going to animate this angle constraint. Now the next part is to animate constraint. We have created the geometry, or we have created the slider crank mechanism in the sketcher. Now we will be animating the angle constraint. Let's animate angle constraint. So let's just go to CATIA and click on the animate constraint button. Click on the constraint which you want to animate. Give the first value. We want to vary from 0 to 360, let's say -360, and give a number of step to be 100, and click on this repeat button and click on the animate button. So as you can see here, our mechanism is going to be revert back after the second value, and also the length is adjusting itself. So first what we are going to do is let's fix the length of the walls, give it a value of 150 so that our wall may not adjust in future. And let's again go to animate constraint, click on the constraint, give a first value to be 0 and give a negative value to the last so that our rotation is in clockwise direction. Again our mechanism is reverting back after the last value, so just click on the forward only button so that our mechanism, so it looks good and pretty good. Let's click on the stop button, but it's faster, so let's just increase the number of steps to be 300. Now let's again observe this. We have slider crank mechanism at a slow speed, animated at slow speed. So today I'm going to conclude here, and thanks for watching tutorials from CAT desk head office. Thank you very much.